All right, so we've been doing graphing trig functions for a while, and you're probably thinking, when is this ever used in real life? Well, how many of you have ever heard of a carnival? And sometimes when you're at a carnival, they have games, they have clowns, and they have rides sometimes. And sometimes they have this very special ride, I don't know if you've ever heard of it, called a Ferris wheel. And usually, if we were in class, I would ask you to explain how a Ferris wheel works. And every year, somebody says that this is what happens. You get on at the bottom, and then they move you over, and then somebody else gets on, and then you move you again, somebody else gets on, move, load, move, load, get to see the top, they load again, they load again, they load again, they load again, and then when you get back down to the bottom, you have to get off. That is not how a Ferris wheel works. If that's how a Ferris wheel worked, it would be the most boring ride in the world. What happens is, after they do that and they load, when you get back, if you're the first person on, when you get back down to the bottom, this is what happens. All right, so you see that then they spin you. You go around and around and around. That video I actually took when we were on vacation a couple summers ago. If you watch when we get to the top, I'm videoing from here. My daughters are actually in that seat. You can see them in the seat in front of us. Anyway, so they spin you around and around and around. Well, you're probably thinking, well, what does that possibly have to do with graphing trig functions? Well, let's look at this idea of the Ferris wheel again, but from a different perspective. Okay, so now you can see that if we think about where you are, your position, and we think about how high off the ground you are, then we can start putting some numbers to this. So if you looked at the side, there were some numbers there, and let's talk about what those numbers were. First of all, it said that the bottom of the graph, the bottom of the Ferris wheel, when you're on the bottom, I don't know what the joke is. Anyway, you were about 4 feet off the ground. And then when you got to the top, you were approximately 58 feet off the ground. And so your minimum was 4, your maximum was 58. Which means from that, you should be able to tell me what the amplitude was and what the midline would be. So the way you would do that is you should recognize or figure out that this is 54 feet between them. And the amplitude would be half of that, so the amplitude here is 27 feet. The midline would be in the middle of those two things, so 27 feet up from the 4 would be 31, and that's also 27 feet down from the 58. So y equals 31 feet is their midline. Now, you probably weren't timing the videos when you watch them, but what happens is it takes approximately 20 seconds to go from the bottom all the way around again to get back to where you started. So that means that the period was 20 seconds. Now, if you think about getting on at the bottom of the graph of the Ferris wheel, and then going up and down and up and down, you should be able to recognize this as a cosine graph that starts at its minimum, so it's a negative cosine. And so from all this information, we should be able to write the function, which would be, well, we have to find the period, use the period to find b. We're going to get b equals pi over 10. There's no phase shift because we started at our minimum. And so we have y equals the amplitude, but it's negative cosine pi over 10 x plus 31. And if we were to graph that on a calculator, it would look a little something like this, mixed with the picture of the Ferris wheel and the video from the Ferris wheel. There you go. There's a real-life application of using trig functions. Just as a note, I was completely lying about that being my video. I stole that off the internet. Those aren't people that I know. Anyway, so if you were like staring intently, trying to figure out, what my daughters look like, first of all, you're weird, and second of all, that's not them. All right. So that's one example. Let's think about another example. How many of you have ever been to or seen on TV the beach? So at the beach, there are these things called the ocean. And what happens is the ocean comes in a little bit higher and a little bit lower based on various things, and we call that the tides. So let's say that we had a dock that looks something like this, and we measured, I should use a blue pen, the water. and we measured where it was in relation to the dock, how far down it was. At low tide, it would be at a minimum. At high tide, it would be at a maximum. Now, obviously, I couldn't go to the beach or find a video of this situation, so instead, I did this. So go ahead and watch this video. All right, so what you should have seen is that at time 8 a.m., the water level was at its low point, and it was 12 feet below the dock. So what we're going to say is that the minimum was negative 12. And then at time, did you see how long it took to get up to its maximum? Or what its maximum was? It might have been a little bit difficult to read those numbers. The maximum was 6 feet below the dock. So we'll say that the maximum was negative 6. Let's see, the time that it reached the top was 4 p.m. So to go from its minimum to its maximum, it was this distance, this time. That is 8 hours. So if I were to graph this a little bit, I would see that it started at 8 a.m. Oh, that's going to be in the way. At 8 a.m. and it was at negative 12. I'll put negative 12 right there. And then at 4 p.m., it was up to negative 6. But that's not a full cycle. That's only half a cycle going from its minimum to its maximum. And so we need to go back down to the minimum. And you might have seen it in the video, but we can figure it out from what information we have here. This is 8 hours, which means that this has to also be 8 hours. Which means that our period here is 16 hours. Now this one's a little bit different because we started at 8 a.m. Typically, we think of time 0 as being like midnight. So we need to account for that by figuring out a phase shift. So go back to brown. Phase shift here would be to the right 8 hours. And then finally we need to figure out our amplitude and our midline. So the amplitude would be half of the distance between the min and the max. That distance was 6. So the amplitude here is 3. And the midline would be 3 up from the min, 3 down from the max. The midline here is y equals negative 9. So from that, we should be able to write our equation. And again, if you look at the curve here, we started at its minimum, up to the max, back down to the min. This is a negative cosine again. Okay, so 2 pi over b equals 16, which means that b is going to equal pi over 8. Make sure you know how I get that. I skip a couple steps when I do that. C over pi over 8 is equal to 8. Well, that's kind of convenient. And so I can multiply both sides by pi over 8 to cancel. And that's why it's convenient. And I get C equals pi. And so if I put this all together, I'm going to get y equals negative 3 cosine pi over 8x. Move to the right so it's negative pi minus 9. And that is our equation for the tides. All right, that's it for today's video. I hope you guys enjoyed that I included other things in the video. It took me a long time to set up that stupid water experiment, so I hope you appreciated that. And talk to you later.